Hello, this is a video for Edexcel Statistics 1. It is the second video in this series, and it will look at calculating probabilities using the Poisson distribution. This is the formula for the Poisson distribution, which was introduced briefly in the last video. Again, lambda is the parameter for the distribution, and it represents the mean rate at which events occur in a given time or space. Here is an example of a standard question. We're given a time period of 5 minutes and the value of the lambda, which is 4. To calculate a probability, I will first write the distribution. So if x is the number of cars passing a point, then this is distributed with a Poisson distribution with a value of lambda of 4. And we're looking for the probability that 2 cars go past. All we have to do is substitute the values into the formula. So e to the minus 4 times 4 squared over 2 factorial is equal to 0.147. In the same scenario, we can also be asked to calculate things like this. The probability that fewer than 3 cars go past. To do this, I will need to calculate the probability that x is equal to 0, the probability x is equal to 1, and the probability that x is equal to 2. I'll work each of these things out separately and add them together, which will give me an answer of 0.238. So here we have the probability x is equal to 2, x is equal to 1, and x is equal to 0. These types of calculations can be long-winded, so it is more usual to use a calculator to work them out. All calculators are different, so make sure you know how to do this on yours. 1. It is also possible to calculate these values in GeoGebra. If you use the probability calculator and select the appropriate distribution, the Poisson distribution, from the drop-down menu, you can change the mean to match your question. So in the previous question, the mean was 4. And we wanted to know the probability that x was less than 3. And you can see that we get the probability 0.2381. The values on the right hand side here represent the individual probabilities 0, 1, 2 and so on for the whole distribution. 1. It is also possible to calculate these using cumulative tables, and these are provided by the awarding body. These represent the probability that x is less than or equal to a number. So for example, if we were looking at a Poisson distribution where the mean was 2.5, we would be looking at this column where lambda is equal to 2.5. And if you wanted to find the probability that x was less than or equal to 4, we could just read that straight from the tables as 0.8912. If you wanted something other than less than or equal to, say for example greater than 2, then you would need to think, well, this is the probability of 1 minus the probability that x is less than or equal to 1, and read the appropriate value from the tables 0.2873 and subtract that from 1. Similarly, if you wanted to know the value of x being equal to something, you would have to think, well, this is the probability x is less than or equal to 3, and subtract from that the probability x is less than or equal to 2. And that would leave you with just the probability that x was equal to 3. So again, you'd look it up in that same column where the mean is 2.3, the values of less than or equal to 3, 0.7576, and subtract 0.5438. Here are the answers to those questions. That's the end of this video. The next video in this series is about the properties of the Poisson distribution.